Here's problem 3323. A 10 ohm resistor, 10 millihenry inductor, and 10 microfarad capacitor are connected in series with a 10 kilohertz voltage source. The root mean square current through the circuit is 0.2 amps. Find the voltage drop across each of these three elements. Alright, so we're given the frequency, and that is 10 kilohertz, which would be 10 to the 4 hertz. We need to know the angular frequency, and that is equal to 2 pi times the frequency. So that's going to be 2 pi times 10 to the 4, which is going to be 6.28 times 10 to the 4 radians per second. Sounds good. The voltage drop across the resistor is the root mean square current times the resistance. And that's going to be 0.2 times 10 ohms, or 5 volts. To find the voltage drop across the inductor, we need to know the inductive reactance, which is the angular frequency times the inductance. This would be 6.28 times 10 to the 4. The inductance was 10 millihenries, which is 10 to the minus 2 henries. So this is going to be 6.28 times 10 to the 2, or 628 ohms, is the inductive reactance. Hence, the voltage drop across the inductor is the root mean square current, RMS current, times the inductive reactance. And that's going to be equal to 0.2 times 628, and that is equal to 125.6 volts. So that is the voltage across the inductor. To find the voltage across the capacitor, we want to know the capacitive reactance, which is 1 over omega times C. That's going to be 1 over 6.28 times 10 to the 4 times the capacitance, which is 10 microfarads, which is 10 to the minus 5 farads. So that's going to be 1 over 0.628, and that is 1.59 ohms. Hence, the voltage across the capacitor is going to be the root mean square current times the capacitive reactance, which would be 0.2 times 1.59 ohms, and that is 0.318 volts. So there we have our three voltage drops. 5 volts, 2 volts. 2 volts across the resistor, 125.6 volts across the inductor, and 0.318 volts across the capacitor.